Let's have a look at this question. Here a function is given, that is 2 cos 2x. We need to find the integral of the given function. Integral 0 to pi by 4 2 cos 2x dx can be written as, here 2 is a constant, so we can take it out. Then 2 times integral 0 to pi by 4 cos 2x times dx. We know integration of cos 2x is equals to sin 2x by 2. Integration of cos 2x times dx equals to sin 2x by 2. Substituting this, we will get 2 times. So integration of cos 2x is sin 2x by 2. Sin 2x by 2. And the limits are from 0 to pi by 4. Now 2 gets cancelled. And then let's substitute the limits in sin 2x. So sin 2 times x is pi by 4 minus sin 2 times 0. That is equals to sin 2 times pi by 4, that is pi by 2 minus sin 0, which yields sin pi by 2, that is sin 90 is equals to 1. 1 minus 0, that is equals to 1. So the correct answer is 1, option B. In order to derive that, just consider theta equals to 2x. Theta equals to 2x. Then let's find the derivative of theta with respect to x. D theta by dx. We will have derivative of 2x with respect to x, that yields 2. And rewriting this, we will get d theta by 2 is equals to dx. Now let's change the limits from x to theta. When x is equals to 0, theta is equals to 2 times x, that is 2 times 0, 0. And then when x is equals to pi by 4, theta is equals to 2 times pi by 4, that is 2 times pi by 4, that is equals to pi by 2. Now simply what we can do is substitute these two here. Now this integration, whole integral will get reduced to integral of, limits have been changed from 0 to pi by 2. So 0 to pi by 2, this 2 remains same 2, and 2x is equals to theta. 2x is equals to theta, so cos theta, and dx is equals to d theta by 2. Dx is equals to d theta by 2. Substituting that, d theta by 2, here by 2 and 2 gets cancelled. Finally we will have 0 to pi by 2 cos theta times d theta. We know integration of cos theta is sin theta, that is from 0 to pi by 2. Finally we will get sin 90 minus sin 0, that is equals to 1. This is another method of solving the problem.